Alright, so this video will be talking about logic and conditions and logical operators in Java. So when writing code in any programming language, you need to account for situations where you need to decide on a certain path to take given the value of the variables at that point in time, or like input. So your program needs to compare values to each other to decide what code to run next, and this is called logic. So let's take a look at what comparison operators we have in Java. So we have the equality operator. So that's the most basic of comparison operators. It just means if the two values being tested are the same, then the result be true, and otherwise it'll be false. So here's how you would do it. Let's say we want to just go ahead and make this real simple. Print does 3 equal 4, and to use it, it's just 2 equal signs. This is the equality operator, equals equals. So this one should definitely print false, right? Because 3 does not equal 4. And then we can try 6 equals 6. This should be true. And we can do, say 43 equals 44. That's absolutely false. So should it give us false, true, false? Let's go ahead and run that. And it gives us false, true, false. Okay, so, oh, but this, the equality operator here, it only works for numbers. So actually, if you want to compare strings, you actually have to use a method called equals. So let's say equals, let's see, hello equals hello, and this should give us true because hello does equal hello here. If we change equal to hello dot equals hello with a capital H, this should evaluate to false because it's case sensitive. So let's go ahead and print out equal here and print that out here too. So we get true, false, just as expected. Okay. And then the opposite of the equality operator is the inequality operator. So we can do system.out.println. Let's say we want to compare 3 and 4 again. So an equality operator is just this. It's just an exclamation mark and an equal sign. So we can do 3 does not equal 4, and this should be true because 3 doesn't equal 4. And then we can just go ahead and actually go ahead and copy and paste this and replace these with inequality operators. This should be false because 6 actually does equal 6, and this should be true. Okay, so let's go ahead and run this. Let's see. Oh, looks like I accidentally got rid of this last one here. Okay, let's try that again. So it's starting to get a little hard to see, but you can see the last 3 is true, false, true. Okay, and then yeah, let's go ahead and clear this out because I don't want to keep printing out these things. So clear that. Alright, let's move on to greater than and less than operators. So you can check if one value is greater than or less than by using those respective operators, and this is how you use them. Print line 3 is greater than 4. this should return false, right? System line 6 is less than 6. This should be false because 6 is equal to 6, not less than. Then we can also do 43 less than 454, and this should be true because 43 is less than 454. So let's go ahead and run that. And that's exactly what we expected. You can also do greater than or equal to, or less than or equal to. So all you have to do is put an equal sign after, like this. So let's see, is 3 greater than or equal to 4? No, so it should be false. Is 6 less than or equal to 6? Yes, because they are equal, so that should be true. And this should still be true. So let's go ahead and run that and see what we get. False, true, true. Yep. Alright, and then there's also conditionals. So let's move on to that. These are our if-else statements. So let's start with if. So these are used when we want to run a certain lines of code when something else, when like a condition is met. So let's say we have int burgers eaten equals 4. If let's say we're doing like a burger eating competition. So if burgers eaten is greater than or equal to 3, so let's say you need to eat 3 or more burgers to win the competition, then in the if loop we want to print you won the competition. Alright, so what do we get here? If we put in, we should get that you won the competition, so let's go on it. And you won the competition, but let's go ahead and change that to 3. And it should still work because 3 is equal to 3. And there it is. But if we make it 2, it won't output anything because it just skipped this line of code and we didn't put anything afterwards. And then aside from if, we can also do else. So let's say if burger eaten is greater than or equal to 3, then you've won the competition. Otherwise, if you've eaten less than 3, and we don't have to put that condition here, but else we print that they've lost. So you lost the competition. And it'll be the same, except now when there's 2, instead of printing nothing, it'll print this one. Because first it does burgers eaten is greater than or equal to 3, and that evaluates to false, so it moves on to these else. So it'll do this one. Oh, whoops. Alright, so you've lost the competition. Okay, so simply put, the first if return false, and therefore you run the first else. You can also do else if, so you add more conditions to it. So let's say burgers eaten is less than 3, so it won't run this, but we want to say that if else if burgers eaten is equal to 2, we can instead write you gave it your best shot, and then we can do an else for losing. run that, it'll tell us you gave it your best shot. Oh, forgot the semicolon. You gave it your best shot. And to give a little more personality, we could even say if burger is eaten is equal to 1, you could write you gave it, no, say an attempt was made. And then if you've lost, that means you've eaten 0 or less, so you didn't even try. Alright, so let's try going with 1 burger's eaten. We get an attempt was made, and if you have 0 burgers eaten, you didn't even try. Alright, so that's basically how if and else conditions work. We can also use ternary operators, which is like a shorthand way to represent an if-else block. It checks a condition, and if true, then returns the left side, otherwise it will return the right side. So here's an example of how you would use that. I don't think these are generally used a whole lot in the programming community. People prefer to use if-else statements because they're more readable, like easy to understand by looking at. But I'll show you how to do it anyways. Say we have an int number equals 25, and we do boolean is even. Let's see if a number is even or not. So if we say number modulo 2 equals 0. So if it's modulo 2 and there's 0 remainder, then that means it's an even number, and if not, then that means it's an odd number. So we do, if it's true, we return the left side, which is this one, and if it's false, we return the right side, which is false. So you have the condition here, and then a question mark, and that's just part of the syntax. And then the 2 values that you can give based on what these evaluate to, and a colon in the middle. So this should return false because 45 is an odd number. Is it even? And then is it even? Okay, let's now run that. Is it even? False. But if we make this 44, it should be true. Is it even? True. Yes, alright, so that's another way to do if else. Let's go and clean this up to make it all cleaner for the next thing that we're about to do, which is switch statements. So you can think of switch statements as almost like a if statement with a lot of else ifs afterwards. So generally you would use a switch statement whenever you want to check for a lot of different possible values of something, and then run the code if there's a match. Yeah, so definitely a lot like using else ifs, but sometimes they can be more concise and cleaner to look at. So here's an example of how to do switch statement. Let's say a number, you have a number that's equal to 4. How you write a switch statement is switch, and then a variable, which we're using number for, and then inside the block we have different cases. So case 1, this would mean that if this number is 1, then we'll run the code that's in this case. So let's say this prints out 1, and then at the end of the case you have to write a break. so that it doesn't run the rest of the cases afterwards. I'm gonna go ahead and just copy this, it's a little easier. Okay. And let's do case 2. So I'll print out 2. Case 3. Print out 3. Oops. Case 4. Should print out 4. And I'm not actually, yeah, let's do one more. Case 5. Case 5. Okay. Oops. And then so it'll basically check for if the number is 1, and if it's not, then we'll check if it's 2, and if it's not, we check if it's 3, then we check if it's 4, then we check if it's 5, and if it doesn't match any of these cases, we can write a default like this, which is kind of the same as like just else. So cases are like else ifs, and default is else. So if nothing else, we're gonna run this default one. Let's write this number is not a 1, 2, 3, 4, or 5. Okay, let me break. Alright. So the reason why these breaks are here is, so if we run case 2 and we print out 2, we don't want it to keep checking the rest of them because we've already evaluated to 1. So let's go ahead and run that. The number is 4, so it should print out 4. And it prints out 4. But let's change it to, say, 1. And now it prints out 1. But then let's go ahead and print out 6. And that gives us this number is not a 1, 2, 3, 4, or 5. Which is true. Alright. So that's switch statements. Okay, alright, let's go ahead and talk about logical operators now. So these are generally used with ifs and else's, and you know what I'm talking about, the conditionals. So logical operators are used to combine the results of more than one condition. So we have like an AND operator. Let's go ahead and say Boolean is cold equals true. Boolean has jacket equals true. So if we want to say if it's cold and we have a jacket, has jacket, then we want to put on the jacket. But let's say else if is cold and does not have jacket, so not has jacket. This is the exclamation is not. It basically just reverses or makes this condition the opposite. System line buy a jacket. Okay, and now let's say else if is not cold and has jacket, then don't put on the jacket because it's not cold. Let's actually go ahead and take away these nots, and we'll just change these values to see how they become different. So right now, is cold is true and has jacket is true. Let's run it and see what we get. Yeah, so it's cold and we have a jacket, so we put on the jacket. But if it's cold and has jacket is false, we should get buy a jacket. Oh, wait, sorry. Let's see. Okay. Alright, sorry about that. Actually, we're supposed to leave these here. I forgot about that. Okay. Go ahead and run it. And it'll tell you to buy a jacket. So, let's try, it's not cold and we have a jacket. So if it's not cold and we have a jacket, we're not going to put on the jacket. Don't put on your jacket. So how this works is basically if both sides evaluate to true, then the whole statement is true. So the reason why this gives us don't put on that jacket is because we set is cold to false. In the condition, it's not is cold. So when is cold is false, this evaluates to true and true because has jacket is true. So since these are both true, this whole statement evaluates to true, and that's why we get don't put on your jacket. Alrighty. So that's the AND operator. Let's go ahead and look at the OR operator. So let's go ahead and start a new one. Boolean. There are tacos. Equals true. Boolean. There is pizza. Let's make that capital. There is pizza. False. So if there are tacos, or, and this is the OR operator, these two lines right here, or there is pizza, system dot print line, we eat good tonight. So basically, this whole thing will evaluate to true if one of them is true. So as long as one of these is true, it'll run this code right here. And because there are tacos is true, this should output we're eating good tonight. So let's go ahead and run that. And there it is. But if we set this to false, then it'll output nothing. There we go. So if they're both true, it'll still be true. There we go. Alright, so that's it for this video. Next video we'll talk about some more loops, for loops, while loops, do while loops, break, and continue. We kind of talked about break already, but we'll go a little bit more in depth next video.